Do you have any problem solving, or you want to discuss?
I wanted to learn about integration by parts.
Yes, that's right. That's another issue. Yes, that's right.
Yeah, because I don't really know much about it.
Yeah, integration by part is very useful.
Mm-hmm.
So what, shall we start from integration by part, or?
Yeah.
Okay, integration by part. Okay. Yeah, integration by part is very useful. Let me go to the whiteboard. Okay, we'll discuss integration by part. Do you remember the product rule in calculus in doing the first derivative? No.
Integration.
Yeah, integration by parts.
Oh,
Do you know the product rule? Before that, can we start with the product rule? Product. Yes, of course you have studied that before.
Yeah. Mm-hmm.
For differentiation, okay. For differentiation. So if you have, for example, if we have f equal to u times v, so what is the first derivative of df? They are all function of x. Do you remember? Do you remember?
It's du dv.
Yeah.
Times v plus.
Yeah. It doesn't matter which one to first. So can we do the dv first, right? dv dx, right?
Mm-hmm.
Plus v du dx. Doesn't matter which go to. It's just a sum, right?
Mm-hmm.
So what does that mean? So this is, we use this all the time, but in many cases we just use this they call the differential form, and first derivative form. So so this is correspond to first derivative. That we introduce the product rule in the context to find the first derivative, right? Mm-hmm. However, if we just rewrite this a little bit, the same equation, can you see? This is the same equation. If I just rewrite this left-hand side, we knowing that it's just product, right? We just emphasize this function can be written as a product of two functions. Mm-hmm. And we still use dx at here. We just rewrite this df as the product, okay? And then here we still copy that. Can you see the left-hand side, the right-hand side are the same. We just copy it, right? That is a v du dx. Can you see that? Mm-hmm. Now, if we just multiply dx, can you tell me what can we obtain? We just multiply dx on both sides. Do you want to participate? Do you want to write?
Yeah.
That's right. So dx disappeared.
Mm-hmm. Because you times it by dx,
yeah,
right?
you multiply d. We just treat dx as a variable. Mm-hmm. Now you still got dv. You still got a lot of things here.
Yeah.
Oh, you do it step by step. So if
you
treat this as factors, what would happen if you multiply dx? Or just write dx?
U and v would still be times by dx, right?
Well, if you just this cancelled, do you agree? Mm-hmm. so does this one. Can you see? Or before that, can we factorize? Can we factorize dx? That's probably make it easier for you. You see, that's u dv plus v du. So can you write the result now, this time? So we just, if not apparent, can we just factorize this dx? That's right. Yes, that's good. So that's very important, useful. So this part, so this form is called the product rule for the to find the first derivative. See, that is formula for the derivative. Okay, that is a derivative. And this formula is for the differentiation. Some textbook call it differential, but I prefer to call it differentiation. In other words, in the first derivative, we found the df dx, right? In this case, we just found the df. Can you see? So that is a difference between the derivative and the differentiation. So sometimes we just, because we can write this notation for the first derivative, right? So therefore, in general, the df can also written as the first derivative dx. Can you see? So that is some background of introducing integration by part. So this is a form we used when we apply the product rule before, but in the context of the integration, we are more interested to df form, because once you know the df, so what happened? Once you know the df, if you have, so that will allow us to do this. If we know the df, then if you integrate the df, what can we obtain? If you integrate this, doesn't matter which is definite or indefinite.
Oh, fx.
Just fx, can you see that? And if it's indefinite, I have some constant, right? So in other words, these two can cancel. Can you see that? So this is very important part in calculus. So this phenomenon is similar. So this is similar to this one. If you have a square, right? And if you square root them, so what would happen?
Oh, you just get a.
You get a. Can you see that? So that in mathematics, this is called the inverse operation. Can you see? Square and square root are inverse operation to each other. Integration and differentiation are also inverse operation to each other. So if they're two mate, they just canceled, right? So why do we mention this rule in this differential form? So I will pick up this one. This is very important. Can you see? This is a formula. This is also called the product rule. But if we use this form to find the differentiation. Do you agree?
Yeah.
Okay. So why we mention this important relation here? If I just pick them up at this corner. So what happens is that if I just integrate on both sides, so what would happen? So we have, if we just integrate, we just put integral. Can you see, can we just write that formula here? D multiply uv equal to udv plus and vdu, right? Oops. Okay. So next, what we do, we just integrate. Can we see? We're just doing integration. So integration can use a green. Can we integrate on both sides? Can you see?
Yeah.
Now, can you simplify this? If we integrate, because the equation, right, we can integrate on both sides. So what can we obtain?
We get.
How about the right hand? How about left hand side first? We can simplify at least one side. Can you see this can be cancelled? Can you see? Just look at this. Do you agree?
Yeah.
So you do integration, and they immediately you do the differentiation. Immediately you are asked to do differentiation. So they canceled. So that is very important idea. So it's called inverse operation. Inverse. I write down this here. This is called inverse. Inverse mass operation. Okay, such as square and square root, and also such as integration and differentiation. If I just write it down here, you know what I mean. So this part, because the cancelings, we all have the product. Can you see? No integration. Can you see? No integration on the left-hand side. Can you see?
Yeah.
So although the integration is still on the other side, right? Is that natural? That's no question at all.
Yeah, I think I get it.
You get it? So this is a product anyway. This is a product, you see. Now, integration by part is based on this formula or relation. Okay. Integration by part say, well, if you know this equation, let's go to next page. If I write this equation down, this is a key relation. So this is based on the product rule, and after integration, we got a UV will equal to integration UdV, right? Plus and VDU. You see, this just comes from product rule.
Yeah.
So therefore, what we can do, we can just rewrite this equation. For example, we can rewrite this as if we have the UdV, then we can simply rewrite this UdA as the difference. Can you see? UV take another integration is VDU. Can you follow me?
Yeah.
So this is an essential formula for integration by part. Okay. Now, how do we use that? So I take one example we can discuss. Okay. For example, if you're asked to doing integration of the say the let's say x and ex dx. Without do you want to try how to solve this problem? Do you think you can solve this problem? Pretty hard, right? You cannot use anti-differentiation. It's not at least not straightforward. Okay. Now, this is a typical example we can apply the integration by part. This is an integration by part formula here. Integration by part. By part means we can do it, divide the integration into several different parts. Okay, part by part. Okay, can we call the integral I? Right. Now, in this case, what we can see is that if we just focus this on, so can you work out the differentiation based on this? So which function, in other words, yeah.
Differentiation.
Yeah. So can we just ask which function? Can we just call this one? Can we call this can we call this a V? All right. Can we just call this V? And this is U. Can we? Now, which function dv will give you first derivative, give you this one, sorry. Okay, this is very special differentiation. What is the first derivative of dx ex? First derivative. This is very special formula.
Oh, the first derivative is
You can write down, yeah. X multiply x dx, are you sure?
x dx times.
Oh, are you sure?
Oh wait, no, just ex.
That's right. Yes. This is the simplest formula, right? Oh, you still have other. Oh, you need to review this basic formula. Can we just review our basic formula here?
Yeah. I
So
thought
we
this
got
is like
not the power function. No, you've confused with power function. Can you write this basic formula here? The first derivative of this
I
power.
thought that you had to do the quotient rule for that one.
Quotient rule. No, I'm just focused on this. Yeah, you can try if you can solve it by quotient rule. But at this moment, I just pick up this simple differentiation, right? So if this is the case, therefore, we will see the differentiation of dx, dex, a function. Dex will simply equal to ex multiply dx. Can you follow me?
Yeah.
In other words, this part, can be rewritten as a dE. Can you see? They're identical, isn't it? They're identical.
Yeah.
So this is the first step. So what we do, we just knowing that this is the case. Therefore, we can rewrite this as x, d, and ex. Nothing changed. Can you see that? Anything change? Nothing changed, right?
Yeah.
Because the differentiation. So we have to remember this idea. So this df is called differentiation, right? Which is very close to the derivative. If you just multiply dx, that is the relation between the differentiation and the first derivative. This is the first derivative, right? Okay, I will repeatedly use this idea. So that is a little bit of change now, okay? Now, if at this stage, I just introduce the u for x, right? And e as whole called is v, right? By substitution, can you see? So what can we obtain? We can got this perfect form similar to our formula. We got du dv. Can you follow me?
Yeah.
So u in this case, u is equal to x and v is equal to ex. All right. Okay, now this formula tells us we don't have to finish this integral, but we can rewrite this integral into two parts. That is integration by parts. Can you see? It's got two parts. Can you see? So many people say, where is the parts? How many parts? Two parts. Can you see? Now you can try. Can you just copy this formula? For the first time, can you use this formula to rewrite the single integral into two parts? I think every time you ask a very interesting question. Yes. The difference between two parts is a difference contains the two parts. Negative, yeah, be careful, the negative. V, you can rewrite down, yes. And dx, yeah. So what is a dv?
It is.
If you want to, perhaps you need to, before you go further, can we copy the formula? because many students get confused at this stage. Don't use U and V. Can we just copy the equation? Okay. If you know the equation later on, you don't have copy. But for the first time, can you simply copy this formula, right? And then replace everything by the function in this problem. You see, this is two function. Okay. Now can we use this function? So don't jump. Don't jump. You follow the formula. You will not make a mistake. So what does U times V? What is U times V in this case? That's right. Yes. What is V?
EX.
Go on. Yeah, you can write a minus sign first. Minus. Yeah, integration. Yeah. Integration. You forgot integration.
Yeah, because V is EX.
You see, yeah. We got two parts. One is still integration. Another is a product of two. Oh, no, you didn't copy that. Oh, you multiply one, did you?
Because DU is 1.
Can we just copy? Don't jump. Can we just copy this integration here before you do integration? Can we copy this equation? You see, because it's the first time. You see, you have followed the rule in the first time. No plus, just D. No, you see, you're not sure.
But this is a times.
No, this is just V multiplied du. What is it? Yeah, that's it. No, not D. Yeah, if you know at this stage, can you replace U by X? U is X. That's right.
So isn't DU just 1?
No, dx is dx. We don't know what is dx is. Dx is not 1. No, dx is not 1. But dx is 1. Can you see? You see what I mean? Okay, now we don't have to integrate first part. We only need to draw the second part. Okay, can you finish the integration by anti-differentiation or whatever method you can use? Okay, we still have dx.
Oh, because the D will be gone.
That's right. You see, so you see, this is the basic equation. Can you see? When you say when you know the if you know the result, you just simply write the result. Okay, which means finished. Can you see? You don't have to write C, but sometimes people write C here. Okay, but at this stage we don't write C. All right. I just focus on this formula. Now, the question is, did we solve this problem? Have we solved the problem?
No, because we don't have the UDV yet.
No. This is our integral. Can you see? This is our integration. And this also our integration. And this is also our integration. So problem solved. Do you want to do more? The integration is solved. If this disappear, you solved. Okay, disappear. That's we solved.
Yeah.
Can we say any integral?
This because we haven't. Oh, this is equal to the same.
No, this is we never try. We don't try. We know it equal to the two parts. So instead of tackle this challenging part, we move to another easy part. Is that clever?
Yeah.
It's very clever, right? It's very clever. So you see, you have very challenging integration, and someone say, "Hey, if you rewrite this one, who are equivalent to the difference between two parts, which is easier to solve. Would you like this thing? Would you like to try?"
Oh no, thank you.
No, thank you. Why? You gain more. You lost nothing. You lost nothing. You gain not. Why not? It's good business.
Also, we also did this thing in class that was like,
Yes, can you just give how to say it? You this river, okay?
Mhm.
It's very hot. The water very hot. So you cannot cross it, okay? Your object is from A to B, okay? But you are not good swimmers. So what can you do? Someone say, if you walk that distance, just walk, and there's a bridge, all right?
Mhm.
So you can bridge, and then you can go here. Would you like to do that?
no.
Why?
Well,
Why
I'll
not?
take the bridge than the river.
Sorry?
I take the bridge rather than the river.
That's right. No,
Mhm.
what I say, because if you are a stranger, you don't know there's a bridge, right?
Mhm.
So but your objectives from A to B, and someone say if you walk to that probably 1 kilometers, right? You will see a bridge. You can cross the river by walking across the bridge.
Mhm.
Would you like to do that?
Yeah.
Of course, because you might be if you're not a good swimmer, you probably never can reach other side. You see,
Mhm.
that is a integration by part. If you have something challenging to do integration, right? Sometimes by introduce the two functions so that we can write the integral, we can rewrite that integration as a du dv. So that is a preparation we need to do. Can you see? If you can write the integration as a du dv, then we can try. We can avoid doing the du dv, which be very difficult. Can you see that? Which is very relatively difficult. Instead, we're just going to the simple one. Can you see? In this case, this is rather simple.
Yeah.
Compare with this one. Do you agree? Compare this is rather simple.
Yeah.
That is integration by parts. Okay, give you a chance to try. All right, give you a chance to try. And
I also had a question because
yes,
we did this.
What teacher? What did your teacher teach you?
This is one thing that we did, but we also did one that was like A over some.
Can write down. You can write down here. You can write. Yeah, you can write. You can write the equation. We can try.
I don't remember the exact equation, but
did the teacher teach you by example, or did the teacher show this method from product rule?
it was. We did that, but we also did this something. When we had,
yes, you show me.
When we have two things that are like.
No, that's just different way to introduce integration by parts. But you show me this is that's different thing. That is when you it's different issue. This is integrate the they call it the you want force? Are you sure?
Oh, no, it's just like something when you have two equations on top of each other.
You probably can write this question, but before we go further, can we just can you try this new formula, new method first? All right. Yeah, it's question 2, because you haven't to try by yourself. How about x sine x dx? Do you want to try? We're dealing with. We'll talk about another integration. You can find that form. But before that, can you just apply the formula we introduced called integration by parts? Where is the dx? You forgot the dx. Oh, it is not that straightforward. So what is it? Doesn't matter. You can keep that. You can don't keep that because we can discuss that. So which is u? You have to ask yourself, what is u? Which is v? Do you think this is your u and this is your v? Are you sure?
Yes.
Well, if that is the case, you only got this form. So uv dx. But in order to use the formula, we have used either u dv or v du. I'm talking about yeah.
Okay.
We are not. This is not what we are looking for. We are looking for u outside or v outside. Can you see? So the objective is to find this by introducing u and v. That is the two forms we are looking for. You try again. So what is your u? Tell the readers what is your u. Now you can you see you have trouble. This
is not u.
No, you have that's not u, but you forgot the dx.
Oh, dx.
Integration must. This is a very general form. Integration must be written this form. Must integration sign and together with dx. Can you see that's called integration? Now, oh, it's cosine. Very close. Yeah, very close. Dx squared. You see, where's dx? Interesting. This is getting more complicated now. Can you see?
Yeah.
So can you tell me?
Oh wait, I did the wrong thing.
Oh yeah.
It should just be one.
Can you keep that? Don't delete, because if you know the how you get somewhere, even a mistake is good for you. All right. This is just notebook. This is not a final report. This is a note, a scratch. It's called a scratch note, scratchbook. So keep everything. Okay. You can try again. That's how artists do. See, artists draw the portrait. They make a mistake. Try it again. So eventually got a beautiful portrait. Yeah, that is closer. Yes, that is closer.
Is it minus cos x or is it sin x?
Well, you have decide. So if you are you talking about this integration, right? So you have integration cosine x dx. Yes, it is sine x. It's a positive sine x. Do you know why? Do you know why it's a positive? Do you remember that integration calculus fundamental theorem of calculus? That is a fundamental. This is calculus. Can you see? So the result of integration, whose first derivative. So in other words, if you compare the df, the result of after integration, must equal to the no case f. This is called the fundamental theorem of integration. Do you remember? This is yes. So that's why if you're not sure about the sign here or any constant here, you just do the first derivative. Can you see? For example, if you're not sure there's a sign, can we just put can we call the c here? C a constant for constant, right? So we just assume this is the right form, but with unknown constant. What we can do, I just demonstrate this method. So in this case, this is our capital Fx, right? Okay. According to this formula, df, the first derivative of d capital X, is equal to, c is constant, right? Equal to cosine c multiplied cosine x. Can you see? Which must equal to this one, which must equal to cosine x. You agree?
Yeah.
So therefore, what is the conclusion? What is the c? What is the c? If these two must be identical, what is the c? They must.
One.
Yeah, positive one. So that is how we use this. If you study the integration for a while, then it's very important to understand there is underlying fundamental theorem between differentiation and integration. Okay, now let's check your result. So you rewrite this sine x as cosine x. Well, that is not sure. So this, you have, so when how do you know the sign here in the first place? I put a question mark here. Do you want to check? Can we just repeat what you have done? So we, in this time, we got integration, which is equal to x and sine x dx, right? Now, if I were you, what I'm going to do is I'm going to rewrite this as a differentiation as dv. Can you see? Okay, and this is our u. Can you see? Now, the question is, what is v? So what is v? The question is, what is v? That is quite new. Yeah, go on. If we just use this as dv,
oh,
so
then
what
v is cos x.
No, not quite. It's almost correct.
Oh, dv? Yeah, v would be
If
negative cos x.
Negative. You see? If we have to trial, okay, if we just found the first derivative of cosine x dx, we got negative sine x. Can you see? And if you multiply the d, we got a d cosine x equal to negative sine x dx. Can you see that? We just multiply dx. Can we? Can you see? So therefore, we know that something wrong with this sign here. So therefore, the conclusion based on this analysis, we must be equal to negative cosine x. Can you follow me?
Yeah.
So therefore, if that's so, u times v, so that's why this is wrong. Can you see? Because in this case, u times v must be negative. Right? So therefore, if I just continue, so we have, so in this case, if we just insist, write this as u dv, and in this case, v must be negative, okay? And if we just use the formula for the integration by part, first is uv, take vu, right? v du, you agree? So the first part is negative x cosine x. Can you see some detail? Can you see? And this is sine. Is it sine now? V is sine. No, V is not sine. V is cosine. V is negative cosine.
Yeah.
Negative cosine x. And dx is just dx, right? It's a little bit too crowded here. Can we just go to this corner? So that's why the first term will be negative x cosine x plus integration of cosine x dx. Can you continue? They have cosine x here. Yes. Yep, you have done it. Have done it. So apart from if the definitely you can put a constant here, all right?
Yeah.
Well, do you want to try one more? Or are you confident? Yeah.
Yeah. Could I learn about the other form of integration?
Well,
because I feel kind of confident with this now.
No. I give you a chance. I give not challenge you. Give you a slightly different one. All right. If you can do that, that's fine. Okay. So that is we got cosine square x dx. Can we manage it to use the integration by part to solve this seemingly easier integral? Yeah, you're a quick learner, but you have to make sure that you know, because you still make a mistake, right?
Yeah.
So unless you can, you don't make any mistake, then we can move to another. I tell you what, integration by part is the most important method in integration. So don't worry about other method if you know this method today. Yeah, you can, you without using integration by part, you can use trigonometry relation, right? But if it's required to use integration by part, then you have to follow.
yeah.
You have to follow instruction. Yeah, do you want to rewrite to how do we introduce U and V?
There's a formula for it, isn't there?
No, not trigonometry. Forget about trigonometry function or forget about integration. We are supposed to use integration by part only. Sometimes you can use more than one method. Sometimes you have to decide what is U, what is V in the first place.
Do we have to replace this with 1 minus sine squared A?
You can try. Yeah, you should. Yeah, if you no, you can't. No.
Oh.
This is trigonometry relation. That you can use half angle, right? You can go to half or double angle, half angle. No.
And this is U. This is V.
Well, you can try. Which is U? Which is V?
This is not U.
So you have to be flexible. You see, when you're doing the integration or calculus, you always consider the basic algebra. You see, when we say the cosine square, so what can we do? How can we write it as a cosine square? Cosine x square. Can we rewrite it as a cosine multiplied cosine?
Oh yeah.
Yes. Can you be flexible? Sorry, x. Then what else can we do?
Then we can make one U and V.
Yes. Yes, please. Yeah, go on. V dash, that's good. Good idea. Did you use V dash? Yes. Yes, the first derivative, yes. So what would be this part? That's right. Is cosine positive and cosine? First derivative is cosine. Yeah. Okay. How do we denote this one? Cosine square? Oh yes, return to cosine square. Interesting. Oh, how did you get that? Wait a moment. Wait a moment. Yeah, that's something very, very interesting. How did you jump from here to here? Does this equal to that? I don't think so. Do you mean cosine square dx simply equal to cosine square x? Are you sure? No, it's not. No. Think about it. It's algebra. You can apply some algebra now. Sine multiply sine.
That's a derivative. That's
No.
the integral of x.
There's no simple way to rewrite the cosine square into the sine square. It's not,
because when you integrate it, is this not how you do it?
Do you mean that cosine square x dx can written as a sine square? You can try.
Oh, I did it because from here to here.
This is not right. This first part is right. This part is right, but this part is not right. You can try. If you can, we just return to that fundamental theorem. Do you want to apply fundamental theorem to check if you are right? So we are trying to integrate this. We are trying to integrate this cosine dx, and we tentatively believe that this is our answer, right? So in this case, these are capital F. These are lowercase f. Lowercase f, not capital Fx. Can you show that the first derivative is equal to f? If you could, then you are right. If you can't, so this is wrong.
Yeah.
Do you want to try? So this is question. In our case.
Oh, I think, wait. So cos squared x is also the same as, right?
Go on. Yeah, what does it mean?
Oh, so do you?
No, that means if you use bracket, that's correct. If you think it's cosine is equal to cosine x, that is wrong. If you rewrite a cosine, that's why it's very strange. We put a square here. Then if you rewrite that, that's fine. Okay, this is fine. However, if you write as a cosine x squared, then that is wrong. Okay. So in other words, you see, if you just look, you see, when you solve the problem, you are not just focused on that particular spot. If you look at the whole pictures, so what is this cosine square dx we encounter? So what is the original question?
The integral of cos squared dx.
Yes, we encounter the same question. We are looking for the same answer to the same integral. Okay. So what can we do? At least what we got the algebraical equation now.
Pardon?
Now we got algebraical equation. We got equation now by using integration by part. So obviously this is from here to here. We use the integration by part, right? As a result, we got the equation. Can you see? Although these are irrelevant, at least can we just help you? If you just rewrite your answer, okay? The original answer, original question is cosine square x dx, all right? Now, can you copy our result based on integration by parts? Can you copy this on the right-hand side of equation? Okay. Okay. This is equation, isn't it? So what can we do without it? With it? What can we do with this equation to solve our problem?
I'm not sure.
No, why did you rewrite that? Why don't you copy that as it is?
Oh, cos squared.
Yeah. Can you see these two terms are identical? Which is to be calculated.
Yeah, so then you'd get to that.
Yes. Well, I think if you that's enough for you to learn today, I think. Because if you can really, I tell you what, if you really understand the trick used integration by part by solving the 3 questions we encountered today, that's a lot of progress. Anyway, okay, go on. Last step. What is our objective? That's right. Okay, we do have time. You want to copy other? You want to write down any other question we can solve? Other type of integrations?
Yes, the one where you have 2 equations on top of each other.
No, you have a sum of fractions, right? I noticed that. Are you talking about you have I can't see that. All right. Yes,
something like that. I think we
right.
did. I'm not sure how to do it though.
No, this is not a question. Do you want to integration? Do you want to integration?
I just want to learn how to do these types of things. Yeah.
No. This is not the question. You better to check your textbook to find the equation. If you just integration part, we just integration by part. We just integration on both sides. That's all. There must be slightly different forms. There are some questions. You have to check. You have pick up the. Can you look at your textbook? Where does this? Where does this come from? Where does this?
I just remember we learned something like that.
Well, I think I can't say anything. you just this is just incomplete expression. Why don't you? Why don't you? Yeah. Why don't you? Yeah. I just share. Give you a chance. You can share your textbook to find the origin of this question. All right. Whether it's example or it's in particular exercise. That is what we need to find out.
Okay, so it's how to do something like this.
You want to write it on the whiteboard?
Should I open the whiteboard again?
Okay, no problem. Go to the whiteboard. You can copy that from your textbook. Yeah, you got the, that's right. Yes. That's right. Where's the X? Yeah, 2X. Yeah. You have to use a new variable. You have to use new variable. Okay. So if this is integration, okay. So in this integration, I originally got we got this. Can we focus on this side? We got this. The number is not important. We can put this number in front. All right. Because any constant can be put outside in the first place. So this looks like this is very close to the log, okay? But the question is, what is this part?
Yeah.
Okay. What can you do? You can just use this substitution. Very simple. It's just introducing. Can we just later can we introduce another variable u equal to 2 5x? If a teacher have told you, you will never forget this. So what would happen if we just put a 7 outside and this I became, can you write down? We just do the how to say, we substitute the variable in order to change the form. Yes, what is dx? In this equation, what is dx? Can we find the dx? Because we got u now,
Mhm.
we have introduced a new variable called u. Can we find the dx in term of u? Du dx, yeah. Yes, that's right.
Mhm.
So can we solve the dx? That's right. Yeah, can we put a constant outside? That's not right.
Mhm.
You mean the -1?
Oh yeah. Mhm.
Okay. Equals, yeah.
Not equal, sorry.
Okay. Yeah. Can you find the result now? Yes, plus a constant, right?
Mhm.
Yeah. Simple. This is very simple method.
Yeah.
Now this part probably involves this one. Can you see? I just help you to rewrite this one. So this must be because this is to power 2, right? So maybe you are encounter this form. You have the how to say it's called a rational fraction in worst type called a rational function. Maybe you encounter something like this. You got x squared minus 5x plus 1. Do you agree? This is, or perhaps there have something else. 1 plus x. Can you see that? So what you encounter? This is a. Can we use a b, right? That's why I ask you to check your textbook. Yes.
Yeah, it's something like that.
Yes, that's right. So if you have so in other words, we are trying to solve this type of function integration. Can we just describe what your question and what is f? F can be written as called a rational function, okay? And u divided by v, u divided by v, okay? And for example, one case is that fx equal to 1 plus x divided by x squared. Can we just take my example, right? -1, okay? And of course, there are many examples. Probably sometimes you got the 1 plus x squared, right? And x squared, and this is plus say any number x minus 1. So this just go on forever, but they all have this form. Can you see? In this integration, when the function can be written as a how to say the quotient form, right? So yes, that is how to. In order to do that, in the first place, this general formula here to help. In this case, is that we often to solve this type of question, we often rewrite fx as this sum. Can you see? As this sum. So this is says x plus a, right? And x plus b. Are you talking about this form? So there are many tricks. There are many ways depending on your form. We can make this argument. In this case, we probably have to put the cx, right? So these A, B, C are to be determined. That is the question. Can you see? this constant is to be determined.
Yeah.
If you can write this equation, then we can solve this. We can use this equation. Can you see? Because each part of them belong to this type of integral. Can you see?
Yeah.
So this question, this is incomplete form, is actually this integration. Can you see? Yes. Oops, I can't draw any. All right. Yeah. Okay. Maybe we can. You can find some question we can discuss next time. Okay.
Yeah.
Yeah. This is it's much simpler than the. This just you just follow this. We just determine this coefficient. Okay. I will save that.
Okay.
I will save this notion. Okay.
Okay, I will
now.
see you